Hello out there, and welcome to our lesson on subsets. So we described a set previously as a group of people or places or things, and then the people, places, or things that were in that set were called the elements of that set. So today what we're going to be looking at are subsets of given sets. So a subset, you probably have some concept of what the word means, is how it sounds and how you probably think, works how you probably think it does. Basically, a subset is going to be creating a set from another set. So I'd like for you to think of it that way. Think of a subset as a set that comes from another set. For instance, let me just deviate from our notes for a second. Let's say that we have this set of friends. Okay, so set A is this group of 4 friends. A subset of this could be, well, let me make a new group of friends from the existing group. So let's say a subset B could be Amy and Bob and Calvin, right? Or maybe we take another subset and we say this new group of friends is going to be Bob and Calvin and Dylan. Or maybe we want another subset and it's, I said Dylan, I meant Dean. Maybe it's Amy and Calvin and Dean. Right? Or maybe we have another subset that's just Amy and Bob. Okay, whatever the case may be, we can go about making these subsets as sets that come from an existing set. Okay, so a set is a subset of another if all of its elements are in the other. So if all of the elements from this set are in this one, okay, then this subset here is this set is a subset of set A. Okay, so I'm going to be saying the word set and subset 800 times in this lesson, and it's going to be annoying, and I'm going to start sounding lispy, so let me apologize right now. Alright, so a set is a subset of another if all of its elements are in the other. And then we have a symbol for subset. This might be like the 5th or 6th symbol at this point. And it looks like a sideways U, and it is underlined. Okay? Now, a subset can be equal to the original set. Okay, so let me go back here again for a second. If I wanted to make a new group of friends from this existing group, let's say it was set F, and let's say I just rearranged them. So it was Dean, and then Calvin, and then Bob, and then Amy. Well, all of these elements here in the new set F were in the original set A, so this is still considered a subset. Okay, it's technically equal, but that's okay by definition. So, a subset can be equal to the original set. And then also, just as a rule, the empty set is a subset of all sets. Now, if you recall, the empty set is a set of nothing. It's a set that contains no elements or has a cardinal number of 0. So technically, what we're saying here is that nothing is a part of everything. So nothing is a part of everything. Empty set is going to be considered a subset of all sets. Okay? Alright, so let's look at some examples here and see if we can't wrap our heads around some of the symbols and reading these things. So we're going to be using sets A, B, C, and D that are given in the box here. And we're going to try to determine if these statements are true or if they are false, and if they're false, why. So the first statement, I'm reading this guy here, says that A is a subset of B. So that's our subset symbol. So when I read that, is A a subset of B? Well, looking at A and B, are all the elements from A, are all of these elements in B? Yeah, 1 and 3 are both part of B. So if the elements from A are in B, then yes, this is going to be true. That is a subset. Excuse me. Okay, how about the next one? It says B is a subset of C. So when I'm asking if B is a subset of C, I'm saying, are all the elements from B, are they in C? Are all of the elements from B, are they also in C? Did this group come from this one? Yes, so this is again going to be true. Okay, how about A is a subset of C? Is A a subset of C? Are all the elements from A, are they part of C? Did this group come from this one? Yes, it did. So that's going to be true. Okay. How about, is C a subset of D? Well, are all the elements from C, were they part of D? Could this group have been made from this group? Absolutely. Still going to be true. Okay. How about B is a subset of A? B is a subset of A. Did all of these elements come from, or all these elements in this set, could we have formed B from A? No. So we're going to say this is false. And let's give ourselves a reason, so if we look back on our notes later, we can remember why we said this was false. So all elements from B are not in A. And maybe I would have given you more room. My apologies. Okay, how about this next one? Is C a subset of B? Are all the elements from C part of B? Are all the elements from C part of B? Could I have made set C using the elements from B? No. So this is going to be false. Same reason as above. Okay, how about A is a subset of C? A is a subset of C. All the elements from A in C. Could I have made A from C? Yes. And then the last one here is empty set a subset of C? Well, by definition, the empty set is a subset of all sets, so that's going to be true. Empty set is a subset of all sets. Okay? And then here, false, same reason. Okay. Now, we have a subset. I think the concept is reasonable. A proper subset is similar. Okay, a proper subset is still a subset. That means the elements are still coming from another group. You're still making a set from another set. The difference is if it's a proper subset, it cannot be equal. If a set is a proper subset, then it is not equal. Okay, so a set is a proper subset of another. If it's a subset, so it still follows the other definition, all the elements come from the other set, the difference is it cannot be equal. And we have a symbol. Now the subset symbol was like this sideways U, and it was underlined because it could be equal. Well, now we're saying it can't be equal, so we just need to take that little portion away. So for a proper subset, it's going to be that sideways U without the underline, because proper subsets cannot be equal. Okay, so let's see if we can apply this here. We have the same four sets, A, B, C, and D. So this first one says, is it true that A is a proper subset of B? All the elements from A are in B and they're not equal. That's what that's asking. Well, yeah, 1 and 3 are both part of the 1, 3, 5 group and those aren't equal, so this is going to be true. Okay, is B a proper subset of C? Are all the elements from B in C? Could I have made B from C? Yes. Are they equal? No. Perfect. That's what we need. We need it to be a subset and not equal, so that's good. Okay. How about A is a proper subset of C? Are all the elements from A in C? Could I have made A from C? Yes. Are they equal? No. Perfect. That's true. Now what about C is a proper subset of D? So C and D, although it is a subset, C could have been made from D. Because they're equal, it is not proper. So we're going to say this is false. In fact, we could say C is not a proper subset by putting a line through it, almost like when you see not equal to that way. We could say it is not a proper subset of D. We could say that C is a subset of D, but it isn't proper. Okay? It is a subset. It's a subset. Okay, but not proper. Okay. Hopefully you're seeing the distinctions there. All right, so now let's see if we can look at a couple of sets and just determine some of the relationships that are true. So looking at number one, set A is the days Monday, Tuesday, and Wednesday, and set B is days of the week, so all 7 days of the week. So what could we say about these two sets? Well, set A definitely comes from set B, right? The days Monday, Tuesday, and Wednesday, they are days of the week. So we could say that A is a subset of B. And because the sets aren't equal, we could also say that A is a proper subset. Proper, so not going to be underlined. Proper subset of B. And that almost looks like a C. Okay. So A is a subset of B. We could say A is a proper subset of B. I could say B. Could I say that B is a subset of A? Could all the days of the week have come from just Monday, Tuesday, and Wednesday? No. So we'll use that slash symbol again. We'll say B is not a subset by putting a line through it. Not a subset of A. And B is not a proper subset of A either. Okay? Number two, we're going to try to do the same thing, but number two looks a little more intimidating. Maybe that's my opinion, but we have the set builder notation that we've talked about previously. So let's try to figure out what we're looking at here. So set A says all x's such that x is a natural number and it's less than 4. So what numbers are we really talking about here? Remember, the natural numbers are the counting numbers. So they start at 1 and then 2, 3, 4, they go forever, except here it says we just want the natural numbers less than 4. So the natural numbers start at 1, and if we're talking about the ones that are less than 4, then all we're really talking about are the numbers 1, 2, and 3. So that's a fancy way to describe set A as the numbers 1, 2, and 3. Okay? Now set B says all x's such that, again, x is a natural number, and this time the x's are between 1 and 3, and we can equal 1 and 3, right? Now, the only number between 1 and 3 is 2, but since we can equal 1 and 3, then we want to include those on the list. So this is really the exact same set. This is still the numbers 1, 2, and 3. So these are two different, really seems like overcomplicated ways to describe the sets that include the numbers 1, 2, and 3. So what can we say about these sets? Could we say that A is a subset of B? Could we have made group A from group B? Yes. Could we say that A is a proper subset of B? The answer would be no, because the two sets are equal, and by definition, proper subsets can't be equal. So we'll put a line through it. Now, could we say that B is a subset of A? Yeah, all the elements from B are in A. Okay, I could have made B using the elements from A, so that's true. Could we say that B is a proper subset of A? No, again, because they are equal. Okay, these are equal sets. Okay? Hopefully so far, so good. All right, so now we've been talking about subsets, and in the first example I showed you with Amy, Bob, Calvin, and Dean, I started creating some subsets. Now, how many subsets can we make from a specific set? There's a rule, okay? If you have a finite set, so a distinct list of numbers that has an exact countable amount, there will be an exact countable amount of subsets that can be created. So any finite set has an exact number of subsets and proper subsets. The number of subsets for any set can be found by raising 2 to the cardinal number of that set. All right, 2 to the cardinal number of that set. That's sort of a little formula that I snuck in there. And then the number of proper subsets is going to be 1 less than that. And I'm going to try to show you, okay? Let me go back to these guys here. But let me make this set smaller, okay? Let's say that set A includes the numbers 1, 2, and 3. Okay? If I wanted to identify all of the subsets, how many other groups can I make using this group of numbers? Well, one subset could be, that was a terrible brace. One subset could be just 1 and 2, right? Or maybe I have 1 and 3. Or maybe I have 2 and 3. Or maybe I have, terrible. Sometimes I just cannot draw these braces. How about just 1? Or just 2? Or just 3? Hopefully you're with me so far. These are all subsets. These all come from the original set A. Since it's just a subset, not proper, we can use the original set, 1, 2, and 3. And then remember, by rule, the empty set is a subset of all sets. So empty set's going to go on the list. Now, can you think of anything else, any other subsets, any other groups that I could have made from the original set A? If you were thinking maybe 3, 2 instead of 2, 3, remember the order doesn't matter, so those would be considered the same set. That would be a duplicate. Okay, so in fact this is the exact number of subsets that can be created from this subset, or from this original set A. So this original set has 3 elements. The formula that I gave you a few minutes ago said if we raise 2 to the cardinal number of a set, we can determine the number of subsets. So equals subsets, number of subsets. So in this case, if I take 2 and I raise it to, what's the cardinal number? The cardinal number was 3. If I take 2 and raise it to the 3rd power, and we can do this with the calculator. If I take 2, and I'm going to use a little AB button here to get an exponent, and raise it to the 3rd power, that is 8. So 2 to the 3rd power tells me that 2 to the 3rd power tells me if I have a set that has 3 elements in it, I will have 8 subsets. Okay, so 8 subsets, and here they are. 1, 2, 3, 4, 5, 6, 7, and 8. And then the next little formula I'd snuck in there said, well, how many subsets, proper subsets would there be? Well, in order to be a proper subset, you just can't be equal, so we would have to eliminate this from the list. So it would be 1 less. So we'd still have the 1, 2, 3, 4, 5, 6. Those 7 would still be options. So 7 proper subsets would exist. Okay. Now you should be able to list out the subsets, but let's say I had, let's go back to this set. This set has 1, 2, 3, 4 elements. If I raise 2 to the 4th power, that means there would be 16 different subsets. I don't know that I necessarily want to list those out. Or if I had another set, let's say I had a set B, and the cardinal number for set B was, 8. I wouldn't ask you to list out all of those subsets, because 2 to the 8th power, that's going to be a big number. Let's see, 2, and use the little AB button. 2 to the 8th power, that'd be 256 subsets. There's no way I would ask you to list those subsets out. But if I was looking at a smaller set, 3 elements, then you should be able to list them out. But in general, you should also be able to use the formula to determine how many subsets there should be. Okay, let's go back to our notes here. So raise 2 to the power of the cardinal number. Raise 2 to the power of the cardinal number, and that's what that says. And then this would be for proper subsets. So this is for subsets. And then proper would just be subtract 1. This is for proper. Okay, so if we look at number 3 here, we've got 1, 2, 3, 4, 5 elements. Okay, 5 elements in this set. That means the number of elements in set B is 5. The cardinal number is 5. So if I take 2 and raise it to the 5th power, 2 raised to the 5th power, let's see, 2, AB button, 5 is 32. That means that this set B, would have 32 subsets. So 32 subsets. And because one of those would be the exact same set that we started with, 1 less would tell me that there would be 31 proper subsets. Okay, let's try that again. Oh, here's 1, 2, and 3, and I showed you these earlier. So this set has 3 elements. That means the number of elements in set A is 3. The cardinal number is 3. So if I take 2 and raise it to the 3rd power, we saw this a moment ago, I get 8. That means there are 8 distinct exact subsets for this set. And because one of those is the original subset itself, if I took that one out of the group, then there would be 7 proper subsets. Okay? So now we could use this for some applications. For example, on number 5 here, it says there are 15 toppings to choose from at Subway. How many combinations of toppings could be added to a sandwich? So don't write this, but think about this. If you're going to get your sandwich, the combinations of toppings. Now, you're going to choose your meat first, right? Maybe you want the BMT or the cold cut trio, or I don't know what else. Those are all my kids eat there. But the combinations for toppings. So you choose your meat, and then maybe you put lettuce on it. Or maybe you put lettuce and tomato. Or maybe you just put tomato. Or maybe it's lettuce and tomato and olives, or all kinds of different combinations, right? What we're looking at are how many subsets could we get from the set of 15 toppings. Okay, 15 toppings in the original set. So if we take 2 and raise it to the 15th power, we'll determine how many subsets there would be. Okay, let me just, so we come back to this later and know what we were doing. So we have a set of 15 toppings. Okay, so if we take 2 to the 15th power, then we have a big number, 2, and then the A, B button, and then 15, 32,768 subsets. That means we have 32,768 combinations of toppings that we could be putting onto the sandwich. That is ridiculous. So this would also mean, it didn't ask this, but it would be 32,767 proper subsets. Okay, but this is the one we want for the number of combinations, because you could use all 15 toppings technically on your sandwich. The proper subset is still an option. So there are 32,768 combos of toppings. Well, that is... It's crazy. It's so much pressure when you're in line to choose what you want on your sandwich, right? Okay, so what I have on this next one is something that I like to do when I'm teaching in a normal in-person class. I like to go through some examples and then give the class an opportunity to try one. Obviously, I can't force you to do that here, but if you're feeling pretty confident in what we're doing and you want to hit pause on the video, try this problem on your own and then unpause and see if you did it right. If not, no pressure. Obviously, I can't force you to do anything. Okay, so Brody's mom is going to allow him to have pets, but his options are limited to a cat, a dog, and or a turtle. So he's got 3 options. It's possible that he could have all 3 pets or some combination of others. So what are the possibilities for Brody in terms of having a pet? So we have a set of 3 pets, right? So then 2 to the 3rd power tells us there are 8 subsets, 8 different combinations. And think about that, right? We'll list them out in just a second here. Let's see. He could have just a cat. He could have, let's do this without the braces, because he could have a cat, he could have just a dog, he could have just a turtle, he could have a cat and a dog, he could have a cat and a turtle, or he can have a dog and a turtle. He could decide to get all 3, cat, dog, and turtle, or he could decide to have none, right? Nothing. So 1, 2, 3, 4, 5, 6, 7, there are all 8 of the options. Okay, so what are the possibilities? There they are. We listed them out. 8 combinations. Did I do this? Let's go green again. Okay, 8 possible combinations of pets. Okay, and if you were asked to list them out, I guess we could put that back in there. Okay, the options were to have a dog, a cat, a turtle, a dog and a cat, a dog and a turtle, a cat and a turtle, a dog, cat, and turtle, or none of them. 1, 2, 3, 4, 5, 6, 7, 8 different options. Okay? Technically, those should all go in braces, but those things are really hard to draw, and I don't want to have to do 16 of them there. You get the idea, I'm hoping. Okay? Alright, one last little bit here, again, just to make sure we're keeping all of the symbols straight and that we can read and interpret some of these little mathematical pieces. So based on our knowledge so far of sets, subsets, and proper subsets, let's try to determine if these statements are true or false, and let's give a reason if it's going to be false, okay? So let's read this first one. What is this first one saying? This is saying that the set 3 is a subset of the set 3, 4, 5. Is that true? Could I have made the set 3 from the set 3, 4, 5? Absolutely. That is true. Okay, everything from the first set is in the other. We're good. Now, if you look at the next one, it looks very similar. Okay, but what is different? What is missing? Well, if we take the braces away, from the 3, then it's no longer a set. Now we're looking at 3 as an element. So can an element 3 be a subset of the set 3, 4, 5? Well, 3 is an element of the set, but only a set can be a subset. So we're going to say that this is false, okay, because 3 is an element, not a set. Okay, now if we look down from here to here, we left the braces off, but now we've changed the subset symbol to an element symbol. So can we say 3 is an element of the set 3, 4, 5? Yes, that is going to be true. Okay? Alright, how about in the next one? We put the braces back on the 3, and we're saying the set is an element of the set. Can the set be an element of the set? Well, the set 3 is an element. No, that's going to be false. This one's false because the set 3 isn't an element. And then it gets really tricky on the next one. This one says, again, the set 3 is an element of this set. But this set contains 1, 2, 3 sets, right? The set, there are 3 sets within the set. So in this case, this set is an element of this set. So this one's going to be true. Complicated, right? Okay, how about the next one? Reading, it says the empty set is a subset of 3, 4, and 5. Well, that's going to be true. Empty set is a subset of all sets. Empty set is a subset of all sets. Okay. Empty set, is that a proper subset of 3, 4, 5? Still true, because it's not equal. And empty set will be a proper subset of all sets except for empty set. It's the only one it would be equal to. Okay. How about the next guy here? Is 7 an element of the set 3, 4, 5? Definitely not. 7 is not in the set. And then is the set 7 a subset of the set 3, 4, 5? Definitely not, because I could not have made that set from the other. Okay, 7. The set 7 could not be made from the set that includes 3, 4, and 5. Okay, a lot of vocab I'm throwing at you. Hopefully you're starting to take it all in. Just do your best managing through the practice, and then as always, if you have any questions or you find yourself struggling, just reach out. All right, take care.